In section 9.4, titled Operations with Functions, we're going to look at 5 different ways that we can combine two functions. First, we'll look at our 4 basic operations, just adding, subtracting, multiplying, and dividing. And then we'll look at what we call composition of functions. First up, let's look at just the notation for our 4 basic operations. We have addition, subtraction, multiplication, and division. Just the 4 basic operations that we have with real numbers. We can do those same things with two functions. So you'll either see maybe f of x plus g of x, or you might see a more condensed form like f plus g of x. But seeing either of these mean the same thing, and likewise seeing either of these means subtraction. These are multiplication, and down here we see a division, a fraction set up. You see this little bit that says provided that g of x cannot equal 0, because as we all know we cannot divide by 0. So this is valid as long as we're not letting g of x be 0, therefore dividing by 0. So let's look at on the next slide, a couple of slides, examples of each of these 4 basic operations. First slide here says find f plus g of x and f minus g of x given we have an f of x function and we have a g of x function. So first we'll find the sum. We'll find f plus g of x. So I want the f function, which is this right here. I'll just recopy it down. And I also want the g function, and I'm going to add the two functions together. So I'm going to use plus and then the g function. So we can see here I've got the f function, the g function, and we are adding these two functions together. Now when we add these two functions together, it is very simply an exercise in just combining like terms, how we would simplify any algebraic expression. The x squared term is the only one in the problem. The x's can combine, I'll add them to make 9x. And the constants can combine, I'll add them to be positive 1. That is simply as far as we want to go. I'll add this here. There is no need to factor. Okay, no need to factor. No need to try and don't try and solve for x. There's no equals 0. There's nothing like that. It's just simply combining like terms, rewriting the new function, and that's it. Now let's look at the subtraction of the two functions. Let's look at f minus g of x. So I start with the f function, 4x squared plus 3x minus 1. And now because I'm subtracting, I need to be a little more careful. I'm going to use a set of parentheses here. I'm going to subtract and then the g function, 6x plus 2. The reason why I'm using the parentheses is because this minus sign has to distribute. And the parentheses there are the reminder to me that I have to distribute that minus sign. So if I just distribute that first, it would be 4x squared plus 3x minus 1. And then I have minus 6x and minus 2. And now we can combine our like terms. So the 3x and the negative 6 are negative 3x. The negative 1 and negative 2 are negative 3. And that is f minus g of x. Again, no need to try and factor or do anything more to that. On this slide, we look at how do we find a product of two functions and a quotient of two functions. How do we multiply and divide two functions? So first we'll take fg of x. Because we're multiplying, I'm going to use parentheses, 6x squared minus x minus 12 times the g function 2x minus 3. We have seen problems similar to this back in chapter 6, it would have been. To do this, we're just going to simply a lot of distributive property. 6x squared distributes to the 2x and the negative 3, giving 12x to the third minus 18x squared. Next it is the negative x distributes to 2x minus 3, so that makes minus 2x squared plus 3x. And finally, it is the negative 12 that distributes to 2x minus 3, making negative 24x plus 36. So there are all the products. Once we've done all the products, now we simply need to add the like terms. So 12x to the third, looks like we're going to add these together to make negative 20x squared, and we're going to add these x's together to make negative 21x. There is FG of x. And finally, let's look at the division. F divided by g of x. The setup, 6x squared minus x minus 12 divided by 2x minus 3. What I'm really looking for here, what I really want to check is, does the fraction reduce? If it reduces, I'll reduce it. If it doesn't reduce, then this would just be the answer. Just writing the problem could be the answer. So let's check for reducing. I'll do it over here. To check for reducing, I'm going to try and factor the numerator. And so this is only going to reduce if one of these factors up here is a 2x minus 3. So I could cancel out 2x minus 3's. So let's just operate under that premise. Let's say that one of these factors is 2x minus 3. That would allow these to cancel out and reduce the fraction. If this factors and one of them is not 2x minus 3, then I'm not really interested. This could be the answer. Alright, so back here, if I'm going to factor this, I'm thinking FOIL. Okay, so these first two must multiply to 6x squared. In order for that to happen, this would have to be a 3x. So that 2x and 3x makes 6x squared. And if I've got a negative 3 here, that negative 3 would have to multiply to a positive 4 to make the negative 12. So let's place that in there. Now all I have to check, we'll do it like this, all I have to check is the outside and the inside product. If the sum of those products is the negative 1x, then we know that that factors. So let's see, the outside is 8x, the inside is negative 9x. If I combine those, absolutely we get negative 1x. So this does factor, and one of the factors is the 2x minus 3, allowing me to reduce. So the f divided by g of x is just 3x plus 4. The last of the operations that we're going to look at involving combining two functions is called a composition of functions. It's the operation that involves placing one function inside of another function. Okay, that's kind of the key. Placing one function inside or into another function. And we've seen this before, to be quite honest. I'll give you a simple example here just to kind of prove it. Say we have just a basic square root of x function, and say we have another kind of simple looking linear function. Say we have x plus 5. It is possible to rewrite, to combine these functions in such a way that would show this x plus 5 going in to the square root function. In other words, we can replace the x or substitute in for the x x plus 5 and write the square root of x plus 5. You don't normally think of, and probably none of us have ever really thought about that. When we saw this in the last section, we were graphing square root functions with transformations. We know what this would do, what this basic pattern looks like, and we know that plus 5 moves it to the left 5 units. But you don't really think of this as a linear function, x plus 5, inside of a square root function. Okay? But it is. It can be thought of as a composition of two functions. So really, most functions that you deal with in this class or any math class are some sort of composition of functions. Now, real quick before we do some examples, the notation. Okay, you'll be typically given two functions. They'll have names. Usually they're f of x and g of x. The notation you're going to see is this. And this is read f of g of x. That's how I would read that out loud. We would not say fog. Some students, even teachers, like to say fog. I don't call it fog, and I'm not going to answer to it as fog. I read it as f of g of x, or f of g of x. Another way to write this same expression is like this, f of g of x. We can see kind of either of those interchangeably.